Hello everyone. So today we're going to cover how to aggregate data over groups in R. So far we know pretty easily how to calculate simple functions like the mean of a random sample from a normal distribution. So it's easy to get, simple summary statistics. Get the standard deviation, that's all good. But frequently when we're running analyses on data sets, we don't just want to calculate one summary statistic for an entire vector, but we might have a data set where we have multiple observations that are grouped by different variables. So for example, if you took a survey of people in a class and you were surveying people's height and weight, you might want to know, well, what's not just the mean height or weight for the entire class, but what's the mean height or weight for groups of people, like men in the class versus women, or upperclassmen versus lowerclassmen, something like that. And there's many ways to do that in R. So first, how do we aggregate data over groups in a data frame? And here's the slow way to do it. This is the way you don't want to do it. And you'll see shortly why. So first let's load up the dplyr package. For example, let's look at again, what else but our favorite data set, chick weight. So we've got, again, weight, time, chick, and diet. Let's say we wanted to know first the mean, if we want to calculate mean weight. So I'll say with chick weight, mean weight, and this is the weight, the mean weight across all chickens. But now let's say we wanted to know for each of the different time points, what is the mean weight? Well, first we have to wonder what the different time points are. So to do that, we can say unique chick weight chick, or no, time. I wanted to do time. And we see, oh, what did I do wrong? Unique with chick weight, time. And remember that unique will give us all unique values of this column. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 if I counted right. Maybe I skipped one, but there's a bunch of these. So, okay, so let's clear this, and we can start by saying, let's calculate the mean weights for time 0. So we could say the time 0 vector of weights is, we can use filter, and, filter chick weight time equals 0. And remember, this will give us a data frame of chick weights, but only at time 0. And that's what we have. So then we can say time 0 mean is the mean of time 0 weight. So we'll take this previous data frame that we just created and just look at the mean of the weights of that. And if I run just this, we see 41.06. And we store that in time 0 mean, and now we can repeat it again for time 1. And we can run both of these. And we have to do this for all of these times. And this is going to take us a long time, and that's silly. Anytime you find yourself repeating the same thing over and over again in R, there's usually a way to do it faster. So here's a better way using the tapply function. And the tapply function allows you to calculate a function over groups of variables. So here's how it works. First, I'll just run the code, and then then we can go through it step by step. So again, we want to say with chick weight, tapply, and if you open up the help, you see that there's three important properties of this. First is x, which is the main data, and the index, which is the grouping variable, and fun is the function that you want to apply it to. So first we'll say x is weight, and the index is the factors, so index will be time, and the function that we want to apply, so let's start with mean. Let's say we want to just know what the mean weight is for each time. If I run this, here's the output. So as you can see, what R has already done is automatically run the mean weight over all different time points. So x is the response variable, the main thing you are interested in. Index is the grouping variable, and fun is the function you want to apply to x for each level of index. So let's do a few of these. Let's say we wanted to know the standard deviation of weights for each time point. You might want to look at this because you want to know, well, how different are the chickens' weights at each time point? Do they tend to get closer together? Do they tend to get farther apart? Something like that. So we can say SD by time, and we'll assign this to with chick weight, and use tapply, x equals weight, and x equals time, time, and fun equals SD. And let's run this, and no errors, that's good. And let's see what's in there. And here we go. Now we see for each of the time points, so time 0, the standard deviation of weights was 1.13, which is quite small. So at time point 0, all the chicks had very similar weights. But then we can see as time goes on, it looks like the standard deviation is getting higher and higher. So the chickens are spreading out in their weights. Just out of curiosity, let's see what happens if I just type plot SD by time. Let's see if R is smart enough to just plot that. Yes, it is. Cool. So yes, we can see the standard deviation is increasing. Let's say instead of the standard deviation, we wanted, let's say the maximum weight. So we'll say max by time. And I just take the same thing, but all I have to do is change the function. Type in max, run this. And then let's go ahead and plot max by time. And it looks pretty much the same. So the maximum weight seems to change pretty much the same way as the standard deviation does. One other thing we might want to look at is just what's the number of observations of weight for each time point. Now, for this data set, it's maybe not so interesting, but you might have other data sets where you want to know how many, just in general, how many men versus women are there in the class. So if you had a data set where we had, I don't know, class, maybe not weight, class height, and then we had height here, index, gender, and then we want to know just how many are there. And the way you can do that is just by using the length function. So how long is the vector of weights for each grouping of time? So I'll say, we'll call this observations by time. Run that, and let's look at this. And not too surprisingly, we have all the observations are fairly similar, but it seems like at time 0 and 2 we have 50, and then it seems to be going down. My guess what's going on in this data set is unfortunately where some chickens are dying over time. So we can see how many we have left over time. Kind of sad, but such is life. So that's tapply. And tapply is really great for quickly looking at the result of a single function of a single variable. It's a good way to just get a quick look at a data set or a vector. But sometimes we want to do more than that. We may want to create multiple different, or calculate multiple different statistics for one or even many different variables in a data set. So how do we calculate multiple grouping statistics from a data frame quickly and easily? And the easiest way to do that is to use pipelining in the dplyr package. Now this is a relatively new way to do this. So dplyr, I think, was just created in the past year or two, and it has dramatically reduced the amount of code you need to do this. So to do this in the past using basic R took quite a few lines of code, and it was pretty annoying. But using dplyr can be really easy. And again, I'm going to start by just showing you some code, and then we'll walk through it. So again, the goal here is to create a new data frame that gives me summary statistics that I'm interested in. So I'm going to call this new summary data frame summary.df. And I'm going to assign this. And the way pipelining works is first you start by defining the data frame that your raw data is in. And then what you do is you use this pipe. I think this is called a pipe symbol. So it's a parenthesis, or not parenthesis, percent symbol, then greater than sign, then percent symbol again. And the way you can think about this means and then, or just then. You'll notice here I put in a pound sign to make this a comment, so R will ignore this. So I say chick weight, then what I want to do is group the data by something. And the way you group data is by saying group by, and then the variable that you want to group things by. So this is the same thing as the index in tapply. One thing about R is the different functions call similar ideas different things. You just get used to it. So for pipelining, you use this. It's called group by, and tapply it's called index. So I want to take the chick weight data frame, then I want to group the data frame by time, and then I want to calculate some summary statistics. And to do that, you type summarize, and then you can define exactly what you want to have summarized. So let's say I want to calculate mean weight. You do that by first saying what you want this new variable to be called, and I want it to be the mean of weight. Now you'll notice here that this function here, mean of weight, is the same thing I did before that applied the function mean to the entire column of weights, but it didn't group it by time. To do that, I had to use a filter or tapply or something, but now I can just type mean weight, and through the pipeline, I already know that the data have been grouped by time. And then I can type, I don't know, median weight is median of weight. What else might I want to do? SD weight is SD of weight. And then when you're doing these summarizing, you usually want to also say what the number of observations there were. And the way you do that in pipeline is by, first I'll call it observations, and use this n parenthesis function. That's just how it's defined. Okay, so, and I'm going to move the observations actually to the top, because usually that might be the first thing I want to see. Comma, let's just make this look a bit nicer again. Let's delete that final comma because I don't need it. I ran out of things to do. I'm just going to get rid of this to make it look a bit nicer. And this should work. So let me run this. And you can see here that now we have this nice data frame where we have the data grouped by time. Again, that's the grouping variable. And here's all of our statistics that have summary statistics on each time. So again, the number of observations. Again, it's the same thing we saw before when we calculated the tapply. The mean weight, which hopefully is the same, is the tapply. Let's just run this again. 41.06, 49.22. Yep, looks the same. And then median weight, SD weight, and so on. Now, what's also cool about this is that you don't have to run these statistics on the same variable. So on all of these, I ran it on weight, but I can easily run analyses on different variables. So let me see, what else is in chick weight? Diet. So let's say, well, diet's not so, I mean, this won't be so informative, but I could say mean of diet. But diet here is just a nominal variable telling us which diet the chicken had. So this this is not going to be terribly informative. I think it'll end up being like 2 for everything. But just so you can see that it works, I'll say mean diet. Oops. Mean diet, and get rid of this closing comma. And let's run this. And yeah, like I thought, so in time 0, the average nominal value of the diet variable was 2.2. And the only reason it's changing over time is because, again, some chickens are dying off in the process of this study. So yeah, so this isn't very meaningful, but you can imagine if you had a data set with multiple variables you were interested in. So for example, if you're doing a survey of a class, you have height data, weight data, salary data, age, then you can calculate summary statistics on any of those different variables using this dplyr function. Now dplyr, this is just a one example of how to use it, but dplyr you can do a lot of really cool things with. So for example, let's say that I want to calculate summary statistics over the chick weight data frame. So let's just look at this again. But let's say that I only want to include chickens less than 10. So let's see what we have. So unique chick weight. I just want to see what chicken numbers we have. And we have chickens 1 through 50. So let's say I want to calculate summary statistics, but I only want to include chickens 1 through 10. Let's say someone said that's what they were interested in. Not sure why, but you can imagine for other data sets, you might want to do this. And the way you can do this is by using the filter function. So you can select specific rows from the original data file using filter. And it's really easy to do that. Let me just copy this. But now after choosing chick weight, I then want to filter chick less than 10. Or let's say less than or equal to, because we want 1 through 10. And then always make sure you include the pipe, the then pipe. So now we're saying I want to take chick weight, and then I want to filter that data frame. So I only have chicks less than 10, less than or equal to 10. Then I want to group them by time, and then I want these summary statistics. So if I run this, then here we go. And you can see that all these values have changed because we're now applying the summary statistics to just 10 chicks, but it looks like we only have 7 observations. So my guess is that not all chicks 1 through 10 were present in time 0. So this is a good way to, this is a good example of why you should include this observations column at all times, because then if I didn't have this here, I might not realize that the data that this is being applied to is changing over time because I'm losing cases. But because I include this observations, I know that, all right, I'm losing some data as a result. And that's data pipelining in R. So I find that using this data pipelining with dplyr is really the fastest and most elegant way to calculate multiple summary statistics over groups of variables. All right, so let's, and then, let's say I want to, all right, let's run this. So we assign the result to summary.df. And then if I want to run some plots, so I can say with summary table plot time, and means, or mean.weight. Summary table not found. Oh, it's because I called it summary df. And here's our plot, and yeah. So of course, once you've got your new data frame, then you can make any kind of plots that you want. So let me just give you a quick example to try. So try creating a table summarizing the chick weight data for each chick now. So instead of aggregating by time, we're going to aggregate by chick. And for each chick, calculate the following summary columns. Observations, which is the number of observations for each chick. Min weight, the minimum weight, and again for each chick. And max weight, max weight. And, oh, why not mean weight? Mean weight. Okay, so try to create a new summary table. Let's call that called summary 2 df. Not the most elegant name, but yeah, with these summary variables. So go ahead and pause the video right now and try to work out that code. Okay, we're back. So, of course, you have just paused it, you figured out the answer, and you've gotten back. It's not the case that you just skipped right through and you're listening to me right afterwards. Of course not. Okay, so I'm going to be lazy, and I'm going to just copy this because most of this is going to be the same. And I'll say summary2.df. And again, I want to take chick weight, but, oh, and I don't need a filter anymore, so I'll get rid of that. And now instead of grouping by time, group by chick. And then I'm going to keep these observations all the same. So let's run this. And lo and behold, this looks like I have, yep, summary observations for each chick. So for chick 18, I only had 2 observations. Here was its mean weight, its median weight. It looks like I got mean diet here. Which in this case, because the diet is always the same for each chick, it's just the only value that was in there. So I could have said min diet or max, it's going to be the same. But I know for each chick what its diet was, what its median weight was, and what its mean weight was. And that's my new data frame. So of course I should assign it so I can use it later. And yeah, and there it is. So if you got that right, very good. Or if not, there's other ways to do it as well. And that is the end of this session.